Alright guys, so welcome to today's video. We're going to be talking about integration in further maths and mathematics. And before I go into that, I want to give a shout out to Boro Emmanuel. Happy birthday to you. I wish you long life and prosperity, big boy. You're a fun guy, a very nice and fun guy, also very intelligent. You're a fun guy, you're a nice and fun guy, you're a good mathematician. You're a fun guy, you're a nice and fun guy. I wish you long life and prosperity. Okay, you're going to do something for me. This video, you're going to like it, you're going to share it, and if I see your comments within 2 hours of posting this video, you get a birthday gift from me. If not, happy birthday to Oboro Emmanuel. Have a nice day. Alright, so I'm making this video assuming that you have a background knowledge on functions and differentials, right? So you know that if you're given a function y, which is a function of x, right? If you're giving it as maybe ax raised to the power of n, you know that the differential of this function with respect to x is given as anxn minus 1. This is the formula of any simple differential, right? But in integration now is different, because if you're trying to integrate a function x, this same function x, mind you, this is the symbol of integration. The formula now is this: your coefficient, you write it back, this n, you write it back. But what you do is that this x, you write it back, this n now, that's the power, you add 1 and you divide by that same n plus 1. Of course, you put your constant. Okay, mind you, if you differentiate a constant, it disappears, but it only appears back when you integrate a function. Okay, that's why I said you need to understand all these function differentials before I start talking. Okay, so I will show you how to use this with 1 or 2 or 3 examples, or 2 examples, then you do one for me. Differentials and integrals are just like words and opposites. For instance, if I have a function 3x squared, if I differentiate this function, I have 6x. Is that not so? You have 6x. If you differentiate this function using this formula, it will give you this. Okay, then if you integrate this differential, if you integrate this 6x now, you are supposed to have this 3x back. How? This 6, you write it back, you write your x back, just like I told you, you write this 2 back. Then what is the power here? The power here is 1. When you do 1 plus 1, you have to come down and do 1 plus 1 as well, and this will give you what? 6x. 1 plus 1 is 2 all over 2. Are you seeing it? When you cancel 2 here, you cancel 2 from here, you have 3. So you are supposed to have that your 3x squared back. That's why I said differential and integration are just like words and opposites. So when you find a differential, you get the integral back to get the function. Okay, so let me use this for 2 or 3 2 examples, then you do one. Now I wrote 3 simple integrals for us to do in this video, but mind you, here I wrote the different ways of integrating a function. We have integration by parts. You can do integration by substitution. We also have indefinite and finite integrals, integration by partial fraction, integration of trigonometric identities, exponential and logarithm function for WAEC level. Now I cannot do all of this integration in just one video. So what I want you to do is, if you have any of this integration that is giving you issue, why not comment that, oh, I make a video for me on integration by parts, or make a video on integration by substitution. Anyone you want, I might take my time to make a video for you on that particular subtopic. But for now, I'm just going to do this. I'm going to do this one and this one, then you do this one for me. Now, number 1, we have the integrate x squared with respect to x. That's what it means. Integrate x squared with respect to x. That's what it means. So we are going to use that same formula. We take the coefficient here, which is 1, then x, we bring it. What is the power? 2 plus 1 all over 2 plus 1. That's it. So 1 over 3, then we have x plus c. Always put your plus c. Okay, especially when you're not giving limits or you're not giving conditions for x or y. All right, then we'll go to the next one. So it's as simple as this. So this is how to get a integral. Look at the other one. We have 3x cubed plus 2x squared minus 5x with respect to x. So when you have something like this, you can easily take them one after the other. Something like this, 3x cubed, right, plus the integral of 2x squared minus the integral of 5x. All of them is with respect to x. All right, so let's do this one first. We have 3x. So what's the power here? 3 plus 1 all over 3 plus 1. Then we'll do that for here as well. 2x. What's the power here? 2, you add 1 all over 2 plus 1. Then we have minus 5x. What do we do? 1 plus 1 all over 1 plus 1. All of them plus c. Okay, so what do we have here? We have 3x raised to the power of 3 plus 1 is 4, obviously, over 4. Then here we have plus 2 over 3x raised to the power of 3 minus